Hello everyone, welcome back to my channel. This is Jess. So today we'll be looking at a coding question that's very similar to a question that I did before. It's called Number of Islands. I'll link it on the upper right corner. So if you haven't done that question yet, I highly recommend you looking at that question first, because this question that we're looking at today is more like a follow-up question to that question. So let's first take a look at the question statement. You're given a non-empty 2D array grid of zeros and ones. An island is a group of ones representing land connected four directionally, horizontal or vertical. You may assume all four edges of the grid are surrounded by water. You need to find the maximum area of an island in the given 2D array. If there is no island, the maximum area is 0. The question statement is pretty straightforward. So you can see it's very similar to the number of island question. The setting, the input is pretty much the same. For that question, you're also given a grid of zeros and ones representing the island. And the basic structure of the solution to this question is also very similar. In a number of island, what we did was to traverse through the whole grid first. And whenever we see the edge of an island, we go into that island, marking every land in that island as visited so that we don't count the same island twice. And once we're done traversing through the whole grid, we will know how many islands are in the grid. And for this question, we also need to traverse through the whole grid. And similarly, whenever we see an edge of an island, so basically, whenever you see a number 1, we also need to go into that island and then mark every land in that island as visited. But for this question, in our DFS function, we need to return a number, that number being the size of that island. Because we're trying to find the maximum area of an island in the grid, so basically every time when you see an island, you get the size of it and then compare it with your current maximum area number. And once you've found all the islands in the grid, your maximum area number should be updated to the true maximum. So let's just start actually coding the solution now. First thing first, we need to make this maximum area variable and we initialize it to 0. And then we check for null value of the given inputs. So if not grid or the length of the grid is 0, we then just return the maximum area, which means there's no islands in the grid. And then the next thing we need to do is create this visited set. So in my previous question on number of islands, what we did was basically just marking every ones in the grid as 0, meaning they are visited. But in this question, I want to do it more formally so that we don't have to modify the given grid. So let's create this visited set. And this visited set will contain all the location indices of the lands that we have visited. And as usual, we want to traverse through the whole grid. So for I in range, length grid, and then for j in range, length grid 0. And if we see an edge, or if we see a land, then we need to run our DFS function. And since the DFS function is going to return a number, and we need to compare it with our current maximum area number, so we update our maximum area number right here. Max area equals max between maximum area and the number that's returned from our DFS function. And now let's think about how to write the DFS function. So first thing, let's declare this DFS. We need to pass in a row and a column number and the grid. For this function, every time it returns a number, that number actually means from this current location that you're passing in, how many lands is it connected to? It includes the land that you're currently on. So say if you're passing in a location where this location is the only land on that island, then this DFS function is going to return 1. And if you're passing in a location that is not a land, meaning that it's a 0, then this location is going to return 0. In the DFS function, the first thing that we need to do is to check if the location is out of bound. So if rho is less than 0 or rho is greater than or equal to the length of the grid, or column is less than 0 or column is greater than or equal to the length of grid 0. And then there's another thing that we need to check. Since we're keeping track of this visited set, we also need to pass in that set. And we need to check if the current location is in the set or not. So if it is in the set, that means it's already visited, so we don't need to count it anymore. Row column in visited. And also if the current location is water, so grid row column being 0, then we just return 0. And then the next thing we need to do is, if it is not out of bound and it is a land that has not been visited, we need to add it to the visited set. So visited.add, we're just gonna add a tuple of the row and column number. And then the next thing we need to do is to DFS traverse on all its neighbors. And once we get the return value from traversing through their neighbors, we need to return this location's value from this DFS call. Return, we need to call the self.dfs function on row -1, and then same column, same grid, the updated visited set, and then plus another neighbor, DFS, row +1, column, grid, visited, and then plus DFS on column +1, grid, visited, and column -1, grid, visited. And in the end, we need to +1, and that +1 is counting this current location. All right, so now let's go back to the main function and pass in all the inputs that's required. Row being I, J being column, same grid, and then the visited. All right, so in the end, we basically just return the maximum area. All right, so that completes the code for this question. And now let's take a look at the runtime and the space complexity for this solution. For runtime, we are traversing through the whole grid, and every time when we see a 1 in the grid, we're going to call this DFS function. And in the DFS function, it will recursively call itself if it matches all these requirements with the neighbors of that location. So in total, the runtime is only going to be big O of R times C, R being the length of the grid, and then C being the width of the grid. And for the space complexity, we are creating this visited set, which in the worst case scenario, it will contain all the locations on the grid, meaning that the whole grid is an island. So the space complexity for this question is big O of R times C, so the same as the runtime. Alright, so that's it for today's video. I hope you enjoy this question, and please try this out if you haven't. If you have any questions or comments, please comment them down in the comments section, and I will see you in my next video. Bye!